All right, ladies, here are your notes for worksheet 4.8a. Make sure you take the notes carefully. If you don't quite finish in class, then you'll have to finish the notes along with homework, and it along with your worksheet 4.7 are both due on Tuesday. Okay? All right, so first of all, we want to consider the problem x cubed over x cubed. Now, the long way to work this is to expand those x cubes. That's how we first talked about it. And then to note that each one of these cancels to a 1, so you end up with 1 over 1, and this answer is just 1. You can also work this problem by our subtraction rule. Now, we didn't do any when the numbers were the same before. We just canceled them out and said they were 1. But the subtraction rule says that if we take the exponents and subtract, we should get the answer. And that gives us x to the 0. We did not look at x to the 0 on our last assignment. Well, what this points out to us is that anytime you get x to the 0, that's the same thing as 1. That's a really weird thing to think about, but that is, in fact, going to always be true. In fact, as long as your base is not 0, any base except 0, raised to the 0 power is equal to 1. It's always kind of interesting to try this on your calculator with some specific numbers, and you can pull that out if you want to. Type in 2 to 0 on your calculator, and it will tell you 1. Type in -6 to 0 in your calculator, and it will tell you that the answer is 1 every single time. It can be something very simple. You can't do this one in your calculator. If you get x to the 0, that's 1. If you get z to the 0, that's also 1. It can be very complicated. You can have several bases on the inside. Lots of messiness in there. It doesn't matter. All of this stuff inside here has the 0 exponent on it, so that entire thing comes down to 1. Now, sometimes you'll see x to the 0 mixed in with something else. For example, if you see 2x to the 0, remember that that is 2 times x to the 0. So it's 2 times 1, and that final answer would end up being 2. All right, the big thing to recognize, though, is that in the midst of these problems, if you see x to the 0, change it to a 1. If you see y to the 0, change it to a 1. Okay? All right, the second concept that we want is to look at when the variable in the denominator has a greater power than the variable in the numerator. And when we did this before, we looked at separating it out or expanding it out, canceling, and then noting that the excess bases would be in the variable. And we just didn't actually show any work for this. We just said, oh, 5 minus 3, and the answer goes in the denominator. Well, you can also work it by straight subtraction. But when you work it by straight subtraction, you're going to end up with some negative numbers. Okay? You're going to get this answer, x to the -2. And if these things are both true, then that means they must be equal to each other. Okay? So here's our key concept here. And if you have a base to a negative exponent, you can flip it over. Think for a minute, do you remember what the word is for flipping something over? Starts with an R. It is reciprocal. So negative exponents are about reciprocals. Without demonstrating this any other way, it works for 1 over b to the negative n also. The reciprocal, if you think about the reciprocal of 1/3, that 3 gets flipped up into the numerator. So the same thing's going to happen right here. Let me give you a couple of examples, and it will be a little bit easier to follow. Okay. If you have x to the -1, anytime you see that, you're going to change that to 1 over x to the +1. Change it up, flip it over. Okay? If you have x to the -3, you're going to flip that over, 1 over x to the +3. When you flip it over, you also have to change the exponent to a positive. If you have y to the -5, you're going to flip it over and make it 1 over y to the +5. So it's starting out in the numerator, it ends up in the denominator. Okay? Likewise, if you start out with a negative exponent in the denominator, you're also going to flip it over. And that means it's going to numerator. It's the reciprocal. If you say 1 over x to the negative 4, that's going to get flipped over and be x to the positive 4. Make sure you change the exponent to positive. So we do that reciprocal again. And keep saying that word, reciprocal. And then we would probably just change that answer to x to the 4th. It also works for numbers. If you have 1 over 2 to the negative 3, you're going to flip that over and make it 2 to the 3 over 1. Okay? All right. And we just do a couple more with numbers. The numbers seem to throw us off a little more than the variables do. If you have the fraction 1/5 to the negative 2, and that negative 2 is on the outside, then you can flip the entire fraction first, change to 5 over 1, and make sure you change it from a negative exponent to a positive exponent, and then we can just square everything inside the parentheses and get the answer of 25. Okay? If you have two variables in the fraction, like this, actually I think I'll make that a negative 3, so a negative 1. Okay? If you have that two fractions in there, you can flip the inside because this exponent here is negative, so do the reciprocal, y over x, and change the exponent to a positive. So those two things have to happen at the same time. And then you can just attach that cube to the y and to the x. Okay? Now let's look at how we're really going to see this. We're really going to see this with multiple bases in the same problem most of the time. So when you have some positives and some negative exponents, you basically just want to do the reciprocal for any piece that has a negative exponent, any base. So think of this as both of these are in the numerator. So set up a fraction bar. If the base has a negative exponent, like the x, then you're going to do its reciprocal. So flip it to the denominator. If it has a positive exponent, you are not going to do its reciprocal. So then x to the negative 5 times y squared is the same thing as y squared divided by x to the 5. Okay, similar example. This time the exponent on the x is positive, so I am not going to flip it. But the exponent on the y is negative, so I'm going to do its reciprocal. Okay? So if the base in the numerator has a negative exponent, move it to the denominator. And make the exponent positive. You have to do both things. Okay? Now I'm going to look at an example where our bases start in the denominator. The bases start in the denominator. So the rule is you only do the reciprocal if the exponent is negative. I'm going to set up a fraction. I'm going to take a look at my exponents, that 1. I'm just going to transfer that 1 over here. This exponent is a positive, so I am not going to do the reciprocal. I'm going to leave it right where it is. The exponent on the y is a negative, so since it's in the denominator, when I do the reciprocal, it's going to flip that back up to the numerator. Okay? So its reciprocal moves up into the numerator. Okay? Second similar example, just going to drop that 1 there. The x has a negative exponent, so I'm going to flip that, do the reciprocal up to the numerator, but the y has a positive exponent, so I am not going to flip that over. All right? If the base in the denominator, if the base is in the denominator and has a negative exponent, then you are going to move it to the numerator. And make the exponent positive. Okay? So at this point, I'm just going to now work a few examples of different scenarios that might play out. And in this first example here, both of these exponents are negative. So when I set up my fraction, this 1 just transfers over. Both of those exponents, both of those bases flip to the top. And if everything flips up to the top, and there's nothing left in the denominator, we put a 1 there. Okay? And if there's nothing in the denominator but a 1, we tend to leave that off. Look at the next example. Set up a fraction, and you're thinking to yourself, do I do the reciprocal or not? If the exponent is positive, do not do the reciprocal. Leave it where it is. If the exponent is negative, do the reciprocal. So this exponent is negative. It starts in the denominator, so I'm going to flip it up to the numerator, leaving me with only a 1 in the denominator, which I'm going to then leave off. You have to look at each problem individually. What does it look like? Which piece am I going to do reciprocal? Okay. In this next example, the x to the negative 3 has a negative exponent, so I need to do the reciprocal. That means it's going to drop down into the denominator. The y squared is not a negative exponent, so I do not move it. Leave it right where it is, which is in the denominator. And since nothing is up there on the top, I got to put 1 up there. Okay? Each problem is going to be different. Each one you have to look at. And start by setting up a fraction bar, and then determine, do I leave it where it is? Does it have a positive exponent, or do I do the reciprocal if it has a negative exponent? So this last example here, x to the negative 2 needs to be flipped to the bottom because it has a negative exponent. Y to the negative 3 also has a negative exponent, so it gets flipped to the top. Negative exponents are about reciprocal. Only do the reciprocal. Only do the reciprocal if the exponent is negative. We are not going to just take everything we see and start flipping it around. Only the bits and pieces that have negative exponents do we do the reciprocal. Okay? Now we're going to take a look at the problems that have coefficients. You know, coefficients and exponents behave differently, so you have to keep them separated in your head. This is 2 times x to the third. You have to think of those as 2 x to the negative third. Sorry, 2 separate things. Set up a fraction bar and recognize that they are in the numerator. The way they are structured is in the numerator. So you ask yourself, does it have a negative exponent? If the answer is yes, do the reciprocal. If the answer is no, do not do the reciprocal. So let's look at 2. Does it have a negative exponent? No, do not do the reciprocal. Look at the x. Does it have a negative exponent? Yes, do the reciprocal. All right? I'm going to write this next example so that it clearly shows that that x is in the numerator and that 2 is in the denominator. I'm going to look at each piece of this, each base, and decide what to do with it. The 1 has no exponent on it at all. It's not a negative exponent. Leave it right where it is. The 2 down here does not have a negative exponent. Leave it right where it is. The x has a negative exponent. Do the reciprocal. Make the exponent positive. Okay? All of these are in the numerator. I'm going to set up a fraction and look at each piece. Now that number right there is negative 3, but its exponent is a 1. It does not have a negative exponent, so do not move it. Leave it right where it is. The exponent on x is negative, so I'm going to do the reciprocal, flip it to the bottom. The exponent on the y is positive, so I am not going to do the reciprocal. Leave it right where it is. Okay? The next example, make sure that you recognize that that x and that y are in the numerator, even though I've written it this way. This is the same thing. So look at each piece. I like to do the coefficients first. Nothing happens to this coefficient. They do not have negative exponents on them. Do not flip them. Do not do the reciprocal. Then take a look at the x. It has a negative exponent, reciprocal. The y has a negative exponent, reciprocal. You have to look at each base independently of the other bases. All right, now there's a few problems that start out as fractions. And again, I just like to set up a fraction bar. I like to take a look at the coefficients, which do not have negative exponents on them. Leave them alone. Don't lose them at all. And then only do the reciprocal if the base has a negative exponent. So x to the negative 1 is going to flip down to the bottom, become x to the 1. And y squared is not going to move because it already had a positive exponent. When you take a look at this next one, you might just ask yourself, which ones don't move? Like right off the bat, which ones are not going anywhere? The 4 is not going anywhere, the x is not going anywhere, and the 3 is not going anywhere because they do not have a negative exponent. When you have a negative exponent, just the y, you do the reciprocal. Since the y is at the bottom, I move it up to the top, make the exponent positive. Okay? Again, take a look at it and say, what's not going anywhere? Which pieces are not moving? And in this case, the 4 is not moving and the 3 is not going anywhere. They do not have negative exponents. Now, do I need to do the reciprocal for x? Yes. Flip it up to the top, positive exponent. Do I do the reciprocal for y? Yes. Flip it up to the top, positive exponent. We probably would leave that exponent off the x as a final answer. Okay. Take a look at this one. Don't start flipping everything you see. You only do the reciprocal if it has a negative exponent. So the coefficient -4 is not a negative exponent. It's just a -4. That exponent's a 1. So we do not flip the 4 and we do not flip the 3. Okay? The 4 is a coefficient. Do I flip the x? Yes. Do I flip the y? Yes. All right, those are the fundamental problems. Now we're going to do some that require you to do a couple of steps to get the final answers to a few of these. I will do more of them in class on Tuesday. All right? So my recommendation, there's a couple of different ways to work this problem, but my recommendation is to do this first. Get these reciprocals done. We have trouble with negative numbers. All of us make more mistakes with negative numbers. Okay? So what I like to do is just get rid of them first. I like to walk through the whole list, set up a fraction, and see what stays in the numerator, what goes to the denominator. If it has a negative exponent, it goes to the denominator. Sorry, if it has a negative exponent, you do the reciprocal. All right? So here's a 2. Does that have a negative exponent? No. Here's an x squared. Negative exponent? No. Here's a y to the -3. Negative exponent? Yes. Here's a 4. Leave it where it is. Here's an x to the -4. Hold it down to the bottom. And here's a y squared. Leave it right where it is. So first thing I'm going to do is move anything that has a negative exponent. Okay? And the second step is to rearrange it a little bit so it looks a little more comfortable for me. I'm going to go ahead and multiply 4 times 2, and then I'm going to put my variables in alphabetical order. I'm going to switch this one and put it in alphabetical order. I just kind of like them to line up a little bit. And then we have a problem we've already worked before. We know how to work this. So we're going to do the one step, the new step. When do I do reciprocal? And then I'm going to end up with a problem that I know how to work. Okay, so I'm going to leave my fraction bar here. There's 8, and that's a 1, so I'll leave that alone. We've already looked at this. 4 minus 2 is 2, and they're going to end up in the denominator. And this is going to end up in the denominator also. Like I said, there are a couple of other ways to do this, and some of you may have a tutor that shows you a different way. If it's working for you and you're getting the right answer, I'm going to accept this other process. This is just the way that I have found this. It seems to me to be the easiest one. Okay, so I'm going to set up a fraction bar. If it has a negative exponent, I will do the reciprocal. If it does not have a negative exponent, I will not do the reciprocal. -3 is a coefficient. Don't do the reciprocal. X to the -2, y to the -3. Both of those, you need to do reciprocals. -2 is not a exponent. It is a coefficient. Just leave it alone. And the y, the x to the 4th and the y also do not have negative exponents, so leave them in the numerator. I like to clean it up a little bit. -3 times -2 is 6. And I like to put my variables in alphabetical order and line them up. And now I have, at this point, we have a question we have done before. 6 goes right here. Look at your x's. 4 on top, 2 on the bottom. That leaves me with 2 on the top. Then look at your y's. 1 on the top, 3 on the bottom. That leaves me with 2 in the denominator. Last 2. Sometimes the problems come at you as a fraction. You still do all of the reciprocals first. If you have negative exponents, do the reciprocal. If you do not have negative exponents, do not do the reciprocal. Set up a fraction bar. I'm going to look at each piece. No reciprocal for 3 and 6. X to the 3rd. No reciprocal. Y to the -2. Reciprocal. X to the -4. Reciprocal. Y. No reciprocal. So I can take a look at that And then make sure you see that we're only doing a reciprocal for the ones that have negative exponents, okay? This is a little more complicated than the ones we saw in the last quiz, but I don't think it's too bad. You still want to reduce your coefficient. 3 over 6 becomes 1 over 2. Take a look at base x, which this time your base x ends up with both of them being in the numerator, and that's multiplication. So what do I do to those two exponents right there? I add them, okay? So that's going to give me x to the 7th. And then down here on the bottom, remember there's a 1 right there. What do I do to those two exponents? I add them, and that's going to give me y to the 3rd. Okay? Last example. Step 1. If all of those reciprocals done. Do not flip over. Do not do reciprocals for negative coefficients. Leave the negative 2, leave the negative 4. They don't get flipped over. Do I flip x to the negative 3? Yes. Do I flip y squared? No. Do I flip x to the negative 5? Yes. Do I flip this y squared? No. Now, I've got them out of order when I did that. So I just want to turn it back around and get them back into order. You can see them a little bit more clearly if they're in order. This looks exactly like one that we had for homework earlier. Take a look at your coefficients and reduce. Watch that negative divided by negative. Negative divided by negative is positive. Take a look at your exponents. There are 5 on the top, 3 on the bottom. So 5 minus 3 is 2, and the excess is going to go to the top. And then take a look at your y's. They are exactly the same, so they're just going to cancel out completely. Okay, that is your notes for this assignment. For your homework, you have the super simple ones on the first page. Okay, and the slightly more complicated ones on the second page. It says it's 25 problems, but the first page is 15 fairly easy, one-step